The next valve is going to be the 2250. Now again, what you're seeing is you're seeing a pressure regulator, and you're also seeing a second regulator, and this one's tighter towards the body of the valve. And again, we still have the copper tube. Now remember, this is an old style valve, so you're not going to get this. You're not going to get this solenoid. You're going to get the black solenoid. Now this model number, this is our low power solenoid, and the model number on this is a 4333-02. 4333-02. That's for our low power solenoid. Now this is our surge regulator, and you're going to see that there is a relief underneath that regulator, and it's there for a reason. Do not put a plug in here. You need to have water coming out of this, and I'm going to explain that here in a minute. Again, everything in the valve, the diaphragm, everything is the same as the rest of the valves. So for the 2000 series from 1 inch through 3 inch. Before you set your pressure regulator, you have to set your surge regulator first. Have to. Because this works off of a pressure differential between the surge regulator and your pressure regulator. So what we do is, again, we have to turn the valve on electrically to do this, because again, we're going to be setting our pressure regulator. So you would undo your set screw, and now either you can go all the way down or go up clockwise or counterclockwise. Because the whole thing that we want to do is we want to get water coming out of this relief on the bottom. And we don't want to just get a drop. We want water to flow out. Once we get flow, what you want to do is you want to set this regulator at that point. Now, if you went up to get water out, you're going to have to go down. And if you went down, you have to go up. Because we don't want a drop coming out of this. That's why this has to be cleared of any rock or mud or whatever you have in that valve box. So this is set. Once you set it, make sure that you take that set nut and tighten it back down again right there. It's a lot easier doing it at that particular point than try to come back and do it later and trying to remember if you did it or not. Then you would go to your pressure regulator, and again you would undo your set screw. And again, do we want to increase pressure or do we want to decrease pressure? So if you want to increase pressure, you go down. If you want to decrease pressure, you go up. Once you set your desired pressure, and again, you're going to be using this Schrader valve on the block assembly, and you're going to put your pressure gauge there. So let's say now we've set it, we've gone back, we've tightened up our set screw, and this is set at 60 psi. How this works hydraulically is that we are protecting the downstream side of the valve with our surge regulator, not the upstream. This is your upstream side. And again, remember I talked about this early on, that all of our connections on our valves are on the downstream side of the valve. All of our nipples are. So this is on the downstream side. So what the surge does is, if you have a lot of elevation on this particular valve, and let's say we have valves on top of that slope. Let's say it's a 100-foot slope. When those valves close, and if they're not a Griswold valve, what's going to happen is they're going to close quickly, and they're going to slam shut. Well, now it's going to create water hammer. That water hammer is going to go back through your line, going down that 100 feet, and you're going to be increasing velocities. So what happens is, this is set at 60 pounds. Well, when it hits the valve, it may be 190, 105 psi. Because again, that elevation change, and again, we're going down a slope, so we're going to be increasing velocities. What happens is, that surge is going to come into the valve, it's going to hit this surge anticipation regulator, and it's going to start dumping the atmosphere at this bottom of this regulator. And once it gets between 7 and 10 psi of what your pressure regulator is set at, it's going to stop. So because this is set at 60, so realistically anything over 70 psi, you're going to start seeing a dumping coming out of this valve, this regulator side. Once it satisfies between, let's say, 67 and 70 psi, it will stop. And that's what it's doing. It's making the adjustment. So this was set at 60. So anything over that 70 psi, this is gonna drain the atmosphere first. Okay? Any questions? Again, you can call me on the phone, and if you want to talk about anything. Okay. Now, these are the normally closed valves. Now, our normally open valves are very similar, except we do have a difference with the solenoid. All of our normally open valves have the copper solenoid, but again, we attach a copper tube to the top of the solenoid. And the reason we do that is because we're actually running water through the center of the solenoid. And what happens is that this happens to be a normally open solenoid, and they look identical except you have this orifice on the top. And our plunger is a little bit different. This is the plunger for the normally open solenoid, and on top of the plunger we have a little rubber nipple. So when it's activated electrically through the solenoid, what's going to happen is it's going to suck that plunger up, and that little rubber nipple is actually going to close that port that's inside. Remember I told you we run water through the center. There's actually a tube inside here. So when it sucks it up, it's going to shut off that water, and when it does that, that water is going to be redirected on the bottom of the solenoid, and we're going to start putting water on top of the diaphragm, and we're going to close it. That's how we close our normally open valves. It's very, very easy to do once you understand it. And a lot of times I'll get calls from people, and they'll tell me I have a Griswold master valve. What model do you have? I don't know. So is it normally open or normally closed? I don't know. Well, it's real simple if you've seen this video, that all of our normally open valves have this attachment on it. Now, our 2160 would not have a regulator on it. It would just be, we would just have a block assembly going with a attachment from this nipple to the solenoid, okay? And again, it's going to come off the downstream side of the valve. Remember this. This is really critical because I get so many calls on the valve's not working. And like I said, the first thing I ask is the valve's installed properly or not? And you'd be surprised how many people install these valves backwards. And because they're in a hurry. It's not because they don't have the experience, but it's because people get in a hurry. They want to get off the job as quickly as possible. Okay. The next one would be a 2260, and that would be your pressure regulator. Now there is a couple differences on our normally open valves too. Like on our 2260, we have a gate valve here. Now this has to be open for the valve to operate. Now in a normally open valve, it's different because once you pressurize your system and you get a couple pounds of pressure and flow, a couple gallons a minute going through the valve's going to open up. The only time it's going to close is if it's actuated through the controller, or if you close the valve manually with the flow control. Those are the only two ways you're going to close this valve. So make sure that this gate valve is open all the way, because if you got it closed, the valve may not work, and then you're going to call me and say my valve's not opening up. And again, I'm going to ask you to look at this little gate valve right here and make sure that it's open. Now there's also a Schrader valve on the 2260, and you actually take off the cap, and again you would put your pressure gauge here, and you don't have to energize this to adjust your pressure on the normally open valves. Remember, the valve is flowing water already, and so if you go in and turn the valve you energize the solenoid, you're going to shut the valve down and you won't be able to adjust anything. So make sure that you have a valve open downstream of the valve. You've got water flowing through the 2260 or the 2160 or the 2265, and you can measure your pressure. And again, if you want to increase your pressure, you go down. Remember to undo your set screw first. And then if you want to decrease your pressure, go up. Okay. And like I just explained on the 2250, the 2265 is the same configuration, except you have your normally open solenoid, and it's not going to be on the block assembly. It's going to be on top of the body of the valve from 1 inch through 3 inch. Okay, so that covers all of the model, the Series 2000s, and again we have different models. Now I'm going to show you a picture here in a little while of what our 4 inch and larger looks like, and that's a flange valve. Now on the Model 2000s, you can install them in two different ways. You can do a globe configuration, which is straight through, or you can order it on an angle, and we'll actually take the plug out of the bottom and we'll put it on the upstream side of the valve, because now when you install the valve, instead of installing it globally, you're going to come in from the bottom of the valve. So all the Series 2000 from 1 inch through 3 inch are threaded, and we call it a three-way valve.